Testing? Yeah, it's on. All right. Thank you very much, everyone, for coming. And future thank you to the people who will walk in. Like the title said, this is going to be a panel focused on client-side proving and explaining it a little bit and talking about what it unlocks. Having said that, I will mostly shut up during this panel and let the bright minds here talk. I think a good start to kick it off are if we could do a short round of intros. Tell us who you are, what you're working on, and why you think it's important.
Okay, so I'll start. I'm Michel Abdalla. I'm a research scientist for Nexus, and currently working on the development of our zkVM. But prior to that, I worked for 2 years for Dfinity. So it was my first work in the blockchain world. And prior to that, I had a long history of working in cryptography, advanced forms of encryption, password-based authentication, and so on. So, thank you.
Hi everyone, I'm Tomasz Stanczak. I'm co-executive director at the Ethereum Foundation. So there within strategy, we see zkVMs and zk-based privacy solutions to be strategically critically important for the applications on Ethereum and for scaling. I am not a researcher or zk engineer, so probably I'll be passing more as the thoughts from Darkra, Justin, and Vitalik, and trying to express how I see it strategically. But if you try to quote me on some zk details, then please don't treat it as the pinnacle of EF knowledge on the topic.
Hey guys, I'm Elias. I'm one of the co-founders of Kakarot, and we've been working for the last 2.5 years on zk proving the EVM.
I'm Maya Dotan. I'm the product manager for all things proving and privacy related at Starkware. Prior to that, I was a security researcher, and prior to that, I did my PhD in computer science, focusing on blockchains and privacy. Yeah.
Super. So you have some of the brightest minds when it comes to zk on the panel. I want to start it off a little bit more high level and ask, what about proving technology do you find exciting? What about it is important to you? Why are we here to begin with?
Maybe we can take a segue. Why are we here in the client-side proving? Because it's very technical, but maybe in a way, I think most of the proving work that has been done in the last years has been related to big servers or big GPU farms and so on. And we're checking out whether the next frontier can be local first proving, so proving things on your local devices that are about you. And the main thing that you get from it is reduced or not, nullified data footprint. So we're excited, I'm excited about figuring out, is it interesting that the best privacy is no data footprint at all?
Yeah, so I agree that privacy and data privacy is a huge use case. Especially, I think we're all here for a blockchain conference. Obviously, this is a major hurdle with the wide adoption of blockchains, as I see it, the lack of privacy in most blockchains. And this is just a technology that has the potential to completely transform this. And additionally, the potential to avoid leaking your personal information, even where you're used to doing that, like online when you have to register for each website, you have to tell a restaurant that you're booking a table at who you are, what's your phone number, what's your ID number sometimes. Like a crazy amount of information that you just simply don't have to share and wouldn't have to share with client-side proving.
Well, in general, very, very excited about the progress in zk, like the recent results with Succinct showing real-time proving, and then separately we have the client-side proving that will benefit from all the progress in general in zk. I think that Justin's project and the Ethereum Foundation project on the if proofs, like tracking and creating this competition between the different companies delivering zkVM, is something that created impression, oh, like we're rushing and we're racing, and it's great. On the privacy side, accelerating those client-side aspects will be critical not only for individuals, where we always care about the privacy and ability to interact with your data, with the chain, with safety of the data, but also institutional clients are asking for that a lot, like for Ethereum to deliver the solutions for their customers to be able to privately interact with the chain. So all of this is super exciting in the sense how quickly it's developing, and it's also exciting in the sense of impact that it will have for Ethereum success.
So for me, actually, like proving technology, I find this amazing because, as I said, working in cryptography for a long time, at the very beginning, this was just stuff that you would see in papers and just to prove that it could be done, but you don't really believe that you could implement. So, and since then, like a lot has happened with like start proofs, zk snarks, and starting to see in real world implementations of everything that has been developed. And now, like more recently, like two technologies that I find quite impressive. First is like folding-based or accumulation-based schemes, which I like because they allow us to like prove things that are very long computations with a low memory footprint that would be great for client-side proving. Like at Nexus, I think our first experience wasn't like our first versions were not the fastest, to say the least, but it's because there were several reasons for that. We were using cycles of elliptic curves, and memory checking wasn't done very efficiently. But there have been advances now with folding schemes based on hash functions and lattices, which seems very promising. And the other part that I find quite nice is all this work on small fields, proving technologies that can reduce the cost that you have with commitment schemes, all the overheads. And I think I find that extremely promising.
So many of you mentioned that clients and proving can do a lot when it comes to privacy. And I want to get into more of the use cases of client-side proving and what you think it unlocks or it can unlock in the coming years. But first, I want to take a little bit of a step back and focus on this privacy angle because it came up a few times. How does client-side proving help when it comes to privacy on-chain?
Okay. So the first obvious use case that is already being discussed and implemented in several places is zk credentials and zk identity. Just implementations of zk protocols that allow you to prove, for instance, that you are an owner of a government-issued ID and you are over 18 without revealing who you are. So, and this is actually even utilized. For instance, I know there are several states that allow you to onboard your driver's license to your Google wallet, and then you don't have to show your ID. You can tap it for certain functionalities, but you can extend this. You can prove you have a degree. You can prove you can prove that you have sufficient balance in your bank account to apply to some loan without revealing who you are. So like the possibilities are endless in terms of like zk identity, I think. Also private payments, like over the blockchain. Today your address is in the clear, the balance is in the clear. You can use zk technology in client-side proving to move your balance either via a privacy pool. You can even prove that you're compliant today with privacy pools implementations. Or you can use something like Circle's idea or Solana's for a private ERC20 or confidential ERC20, something like that. That's all very interesting.
Anything to add?
Depends if you want to jump back or...
Well, maybe, I think maybe if we're taking a step back on the privacy side anyway, what about client-side proving specifically makes these use cases possible or more accessible than they were before?
So if you prove something, it means that someone has written some sort of program that is checking something. So when we talk to zk Identity, your government has signed your passport with like some kind of root authority, and when you're proving to someone that you have a valid passport, you're in fact proving that this signature from the government is valid. So when we think of client-side proving, what we're saying is we've written a provable program, a zk program, a zk app, a v app, whatever we want to call it, and that program encodes the logic of the government has signed my passport. And what wasn't possible a few months or years ago was to run this specific program on a low memory, like a low-end device, like my phone. And so you would typically send this computation to a big server. This is what is done today for succinct, but this is what is done today for Stocknet. So, and when you send that computation to a distant server, that server is going to read all your information. So you're essentially leaking your information, and you come back to the square one, which is sending a picture of your passport to intermediary. So the next frontier is, can you do decently hard computation on a low, like a really cheap mobile phone? And if so, that means that you can do selective disclosure of anything in your life, whether that is your consumption, your driving license, your passport, and all those things, and you kind of can programmably interact with many more protocols in a safe way.
I think maybe what I find particularly promising in the technology is that not only at the time when you start interacting with others, but also at the time of registration, you can keep all the data private. So practically you never disclose any information, and you can attach yourself to a specific group or pool, and then later practically use it in the P2P conversations. I think this might be an extremely powerful concept when you can reach out to someone without blockchain, without anything in the middle, and say, look, I have a proof that a few years ago I registered as a legitimate passport owner, I have an identity, I'm a person, maybe proof of humanity, and we can establish a conversation. So it creates some kind of really strong protection against surveillance of private conversations, some kind of P2P messaging, P2P transaction systems that almost pop up outside of blockchain even. So I think this is inspiring if that works this way.
I think I can even add to that a specific example, right? So today, if you register to Kraken or any type of service like this, you're requested to upload your government ID and also take a photo of yourself, and then you send it off to Kraken, and some human there is supposed to match this information and make sure everything works. But you can implement this in a program, like for instance, any general purpose prover, like you write in Rust, you write in Cairo, it doesn't matter, a program that actually does this operation, if it's a face recognition algorithm, it doesn't matter, you implement it on the Kraken app. And then you take a photo, you have your passport in your phone wallet, and your phone camera captures trustedly a photo of yourself. Comparison is done locally, and a proof is generated, and you can onboard without ever revealing who you are, but it's completely proven that you are who you say you are, you just don't say you are, yeah? So.
I guess even if you don't take it from the perspective of cypherpunk, which you're allowed to do, and you're more interested about the compliance part, or even business creating part, every month, even last month, we saw that if you keep a lot of records of your user in databases, if they get hacked, you're liable for all the information you're leaking. So at the end of the day, I even think that businesses will be interested by client-side proving for the sole reason that they are no longer liable, or even they're not even taking any risk. They can still maintain all the business use cases of KYC, knowing their user, even building a profile of their user without ever being able to be hacked and exploited for the data. And I think that's a cool.
And it's like we are complaining about KYC when you have to fill it in, right? Like when you're on that side of the user, but I had this like very doubtful pleasure of being on the other side once, like executing this procedure as an organization that asked the KYC provider to execute it. It was a terrible mess. I mean, like the way the IDs were treated was just like so disappointing. And then you're absolutely not surprised that all of those IDs uploaded, like passports uploaded, are just like scattered over internet. Because those companies are just like competing for the cost of processing, and there are so many of them that are much lower quality. It's uncontrollable. And definitely if you're an organization asking the KYC provider to execute that for you, ideally you would always work with the solutions that never request any personal data. You don't want to have that responsibility.
Well, most of the points that I had in mind were already mentioned, but as I said, I think to me, client-side proving is like, it's essentially when you're focusing more on the privacy aspect, trying to review as little as possible. And as I was saying, like the liability aspect, I think it's extremely relevant because all this information, like I'm always afraid whenever I have to share my documents that what will happen with can I trust the company that is using that information? And if you're only using that if you can only review what really needs to be reviewed, and that's what client-side proving would allow you to do, it's great. I heard recently that was it Google who implemented added to their wallet the proof of age verification, which I think it's quite impressive because they have to do it in a very, very strict requirements too. So it's not only Web3, it's like it's important for Web 2.
But additionally, like what you've said is really true. Like prior to working at Starkware, I worked at Intuit. And we had like entire departments to maintain that the data that we do keep is compliant. Like this was a huge cost to the company to make sure that you're compliant with data keep. If you don't keep data, then you don't have to do that.
I think one caveat, if I wanted to be the advocating for the devil, is how do you maintain knowing your app user such that you can recommend to them content to maximize retention. It's like everyone likes to use their music streaming services like Spotify, YouTube Music, because the music they recommend to us is extremely accurate to our taste. And many apps work with this assumption that the more you know your user, the better the app. So you have to know a way to how to compose privacy with good UX, because you can deactivate in Google Maps history, for example, to prevent Google from remembering where you went. I tried this for like a couple of years, and then it was so annoying because I was like, where did I go the other day? I want to go back there, and I was lost. I know it can feel a bit dumb, but in a way, comfort has come from apps knowing you. So I wouldn't know how to fix it.
You can monetize your data. You can sell your data to this service provider, and then they can still learn everything that they need to learn to train their algorithms, but you are not a commodity.
I think there's an interesting question as well, which is here, like, okay, teleport to 5 years in the future. How is assume client-side proving as being adopted and that things go well? What is the form factor? How does it look like? Do the end users interact with it? Is it mostly from the side of, like you mentioned, businesses who run it in the background and people don't know that it's happening, but they have certain, like everyone's privacy and ownership of data expectations have just leveled up 10x? How does it look like? How does this live in the world?
I think it's invisible, that's for sure. I think it creates a different kind of, if your data comes from you and you kind of own it, it requires you to have some kind of data store. And I think the most probable way is that it comes from in the form of a wallet, kind of what Google has today, the Google Wallet, or a world ID, or maybe any kind of big group that is able to have locally your data in a very friendly way, maybe kind of like the Apple Wallet. And in the same way, when you do Face ID, I think you're unlocking a private key with your face. Kind of the same thing would occur, like you would register your passport, and then you would just use probably Apple Wallet to generate a disclosure of a specific part of your passport and compose it with other proofs. And I think the main thing that we're going to get in 5 next years is composability. And because it's possible today, like I tried the Self app, it's pretty good. There are other apps, World ID works well, Rarimo works well. You can already scan your passport and generate zk proofs of it. It runs in a TEE, but it's as close as we get to good UX. And the main problem is you cannot compose that proof of being 18 with being a power user of the Nexus, like a Nexus Tech as a beta user, and compose it with being the top 10 equitable user on Starknet, and being like a Nethermind intern. You cannot compose it to have like a very strong dashboard of credentials. So I think this is the main challenge.
And being Nethermind intern opens a lot of doors. So yeah, I think it'll be a very invisible experience, or maybe very similar to what we see nowadays with maybe like TLS or like the HTTPS. So when we go to the websites, you see obviously that there is a lock, and it makes people feel, oh, right, there's something there. And you can start digging into it and set maybe like the privacy and security settings. It's just that the protection level will be much better, and probably there'll be regulations demanding companies to execute it with privacy. So all of that combined might be very similar to nowadays experience with privacy, with accepting what you're happy to share, and it'll be all about what kind of delays you'll be expecting in execution. But should be relatively invisible experience, maybe more like imposed on the companies, or as we mentioned, because of lower cost, the company will be just choosing this one. It's like less of the risks of being sued over the data leaks and GDPR compliance and so on.
And how do you think that, because I think so far we haven't said the word blockchain much. So how do you think that a public blockchain adds value to a scenario where you have client-side proving?
So I think the blockchain obviously would act as a public registry for many use cases. Like, so if you have, like entities would be able to issue credentials on the blockchain, and you could, in like a semaphore kind of protocol, prove that you belong to a set of people that own a credential and use that on. You can have a registration of like people that belong to a domain for a company, and then you can use a zkMail type of thing to query this domain to make sure that you're not being phished. Like the anti-phishing, I think it's a very big use case for this type of thing. So it kind of cuts out the trusted middlemen for a lot of things.
And is there an aspect here of a public square that is as neutral as it can be, where proofs are posted and you cannot really redact them or take them away, so it adds an element of fairness as well?
Yeah, maybe. There is a case for also not needing blockchain at all, because if you want to, if you prove something, someone wants to verify something, there's a chance that there is only one person who wants to verify that fact, and so you would provide that proof over P2B, and you would never need to settle it. If you want to broadcast that proof and for people to be able to check on it after or compose with it, then you probably need the blockchain to have this nonce property and also generalized property.
Yeah, most likely blockchain will be here about like certificate route, like the public space where you can verify like some kind of credentials claims that are certified by other institutions, and then you'll just combine it with local data to just execute like programmable actions on your data by borrowing the information about the claims attestations from the past certifications. So I can, without disclosing my data, I can have the claims on some kind of university degree, past work experience, any type of attestations, and then combine it by just like disclosing selectively what I would like to disclose. So blockchain will be relevant for that notary attestation aspect, where you don't want to involve other parties at the time of processing, right? So I can connect peer-to-peer with someone, but every now and then I'll be matching my data with some claims about my identity, and I'll be able to really manage all of those identities separately. So you don't want blockchain at the time of interactions. That's what be slowing things down, but you want to maybe like reach out for some subset of data. So your counterparty can even store like the local copy of blockchain without reading the updates, at least to have some, like if I have a university degree from like a few years ago, then I don't have to update it every day, right?
I think also like you could use the blockchain as like a history of proofs that you've already supplied. So I'm going to a bank now, I can prove that I already got and repaid a loan from a bank in the past. So that can be written on the blockchain. I don't have to reveal anything about myself, but I have a proven history. It's kind of too complex to keep locally a lot of times, but you could use a blockchain allegedly for that.
Yeah. Well, to me, the link is not very clear. Whenever I try to think about the two, it seems that I'm always trying to find applications that justify the use of blockchains for this. But I'm convinced by all the use cases that you guys mentioned. But to me, yes, we can use blockchains to settle, to maintain history and everything. But yeah, to me, the link is not very clear.
Maybe also as a store of the just the type of actions that you can execute. So when you think of smart contracts, it's really to define the interactions, contracts that counterparties can enter into. So in the past, we would be very limited by just saying, well, you don't want to store the private data on chain or even the hashes of private data on chain, but you would like to borrow from the chain some like contract templates and enter into contract template by just like feeding some data to just clarify that you're actually allowed by that template to enter into that interaction, that you satisfy the requirement of compliance. Then you can have real like counterparty to counterparty business arrangements or the significant value notional, and just say that, yeah, you both, for example, confirming that within your jurisdiction, the other counterparty will be able to like claim the reveal of data if they have to sue you on non-delivery, for example. There's lots of examples in here, I think.
Also, perhaps not related to blockchain, but going back to the store of credentials, today we have mostly like countries signing on documents, but APIs and servers or like data source providers don't sign on the data, so it forces people to use zkTLS and other forms of protocol, which are essentially asking a TE to attest that the data you're receiving from a backend is valid. I think in 5 years, it is likely that data providers are going to sign the payloads they send, and it could be a good place to store their certificate chain.
Great. We have about 1 minute left, which is not enough time for the next question I'm going to ask, but I hope the moderators are merciful. Let's go back to the use cases question. And you're all either using or thinking of using client-side proving. What is the thing that you're most excited about that you're working on at the moment related to client-side proving?
I think for us, it's we're very excited about Ethereum proving and the Beam chain and every effort to Snarkify Ethereum. And we're trying to see if it is possible to take a step aside, and instead of proving Ethereum on huge farms of GPUs, like 160 GPUs, it is possible to prove Ethereum on a decently sized machine, and we would call it like local proving, because it would be one CPU, for example, on an M4 Mac, and at the same speed. So I think that's the next frontier. We're willing to see if that's possible with Stu and Caro and 31.
Yeah, so on top of that, I think we hope that the Starknet state could be proven locally with Stu, and as well as any type of thing that has to do with trusting AI, like verifiable AI. I think this is a use case that's going to become very prominent. Like there's no real good solution cryptographically currently for proving that some output was produced by an AI model. And so client-side proving could be, or proving in general that's not on huge costly machines, could be a really, really good use case for this.
Yeah, I think maybe like proving them I'm a journalist and that I recorded some video with my own camera would be a pretty nice use case. We've been working, like before EF at Netamind, we've been working a lot on this post-truth idea that how do we start proving in the future any events that happen remotely. There's lots of challenges there, and I think that all these technologies together with hardware solutions, with the proofs, with the ability to attest, and they'll come together as like a big defense line against the AI fake data.
Yeah, I think the use case that you're saying of AI, like the potential, like there were a few talks today mentioning about the use of the AI for DeFi, and actually I thought it was very relevant, and we're going to be in a world where a lot of DeFi will be done by AI agents. I thought that was insightful, but as I said, like there are lots of issues with trusting the output that you get from AI, like where the data comes from, and which kind of model. Like there was an invited talk at Eurocrypt a couple of years ago, because that mentioned the fact that AI nowadays is used also for a lot of important life decisions, like if you submit your application to get a loan, how can you trust that there is no bias in the processing of the application? And this is all starting to be done automatically, and it's very important for us to have some type of guarantees that there is no discrimination, no bias, and that actually the real model, the proper model is being used. So, combining the two, it's unfortunately two very time-expensive technologies that combining the two make it work is going to be a challenge, but this is what research is about.
Fantastic. All right. I'm looking at the back of the room to see if we have any time for questions.
Isn't it written on the screen that we have 21 minutes left?
I don't think that's us, because we've been talking for half an hour. Oh, we have the whole hour. Oh, okay. Wow. Well, that was not in my invite. All right. Well, does anyone have any questions? Let's start with that.
How can you use client-side proving for on-chain gaming? How can we use client-side proving for on-chain gaming?
That's a curveball.
I guess maybe, like all those Trackmania problems with proving that you're not cheating while playing. So I guess those might be examples. You have like proving that your hardware executed some actions specifically and sending those proofs while playing. It could be pretty cool. Like that's a big topic now in gaming for sure, like cheating on the records.
Yeah, proving that you, like if it's a strategy game, proving that you have like a winning strategy without revealing it. Yeah, also.
So there's the elements of privacy that go back into it, but now it's used within a game essentially.
Yeah, but also if it's very expensive logic to run on chain, then you can run it off chain and then prove the state, and then you just verify the proof. It's not necessarily even about privacy, just about not having to re-execute on chain the entire logic.
Then maybe I want to dig a bit deeper into the privacy topic again, because I think it's something that came up repeatedly. Try to paint the world in, okay, let's again take an arbitrary number, let's say 5 years, right? Today we have, I know, difficult, but we have public chains, and well, they're called public chains for a reason. They're permissionless, yes, but also a lot of what is posted on there is public. How does the world on a public blockchain look like in 5 years from a privacy perspective?
Like, I think in the ideal world that I am considering, end users would be using blockchains. They would not know that they're using blockchains, and everything would be private, but they would also not know this. They would just like be indifferent, but everything would work seamlessly. It would be cheap, seamless, and private, and the end user will never know that this is happening. I think that's the future.
I guess in 5 years you have like a personal device where you upload all your life information, but you know that it's never connected, and it interacts with blockchain for all the attestations, information, and for initiating contracts with other agents. So be able to tell that device that I would like to find a new job or apply to university, or that I would like to travel. And the device will just start interacting with blockchains to enter into contracts, and will start sending a lot of proofs confirming the data that I have. So like when you see all of those devices that try to record all your life, all your data, all the information, everything that you see, this is super scary that this would be like somewhere online and leaking. I'm like, you can just imagine, right? Like that 2 weeks of your life just like leaking to someone, like everything that you've been doing. Instead, if you could, like 5 years is a long time, so you can have pretty powerful devices that pick up the important information about your life and selectively choose to represent you in all the interactions. So then you have this like AI to AI interactions with the contracts on chain, and the contracts on chain being the layer for agreements, for payments processing, right? If I want to apply to university, I want to make a payment to execute the application, I want to submit that I confirm that I want to apply, that all like appear at the examination date and so on, or maybe send some list of credentials that I satisfy, and then I want to relate to it.
I like that idea that we could actually put a lot of things into a device, but I'm also very scared that if you lose that device, or who has access to that device nowadays, how do we, like, there is the other aspect of, as you said at the very beginning, I guess it's good to be a device that is offline, but guaranteeing those things, especially once you connect that.
Well, losing our phones nowadays, it's similar, right? Like we have lots of pictures there, recordings, stupid things, all the messages from the last days, and they are protected, like tamper-proofed and so on, or encrypted. So I guess with these devices will be the same. There's like even more risk that if it leaks. But it already happens with the phones, with the laptops. So I think we'll have a very similar situation here.
I agree with your point, but that's something that I always have in the back of my mind when I traveling and have to deal with, you have all this private information stored and knows more about you than probably you know yourself. But I agree that it's even worse if it's not on your own device, but if it's somewhere else, and that you have no control over, that it makes it worse.
Arguably, if you talk frequently enough with an AI agent today, it has a memory component. So if you talk for the 5 next years to your pro ChatGPT, it is likely that it will draw some kind of transcendental profile about you, and now such that they could manufacture that device for you. in a very privacy-preserving manner, of course. No, I'm kidding. Probably no more public blockchains in 5 years. Only compliant blockchains that are semi-private, like private enough. It depends what you want to do. It's always the same thing. If you want to be part of the nation state, you probably want to be compliant and private. I think Vitalik tweeted about cashless societies in North countries that are rolling back because it's not safe enough to go cashless at this point. So you need a robust way to go cashless without the ability to shut down someone's life in an instant. So probably blockchain is a good use case for it.
So you're saying, if I play this back to you, you're saying you keep the permissionless aspect, but you switch to everything is private in a compliant manner.
Probably, yeah. And then if you're excluded from the compliance zone because you're in some place that, then you probably need to interact with the public blockchain with a non-wallet, or I don't know.
So you have a web versus dark web scenario.
I'm not an expert enough to know, but in the likely event that nation states and fiat is still a thing in 5 years, it is more likely that stable coins become the main use case for on-chain activity, and then compliance becomes the pinnacle of that system. And then you have economic zones of which can be excluded of or included in, thanks to local first zk proving. So if you prove that you're part of a club for the past 10 years and you satisfy, you may enter economic zone. If you fail to prove that you are not from North Korea, you will most likely be excluded of some economic zones, and then you can build your own economic zone, I guess.
Tomasz, any opinions?
Yeah, no, I started drifting even more forward because I was exploring all those future concepts of the automated verifiable surveillance systems when you actually adjust the local laws based on the preferences of people living in the space. So it's very futuristic, where if you have a group of people living in a city, the systems in the city kind of keep asking you for your preferences. You don't disclose any information about identity, but you say, what are your preferences for laws? And it keeps telling you what is forbidden and what is allowed. And then also if it detects that absolute majority of the population have a preference for change of law, maybe because of migrations, then it adjusts the laws. So it's self-creating the local legal systems and negotiates with you what you agree to. And it also allows you to execute self-policing mechanisms with surveillance drones, answering questions about what they've seen and confirming, for example, yes, this person broke the law if you show them the person, and generating proofs. So this is, I don't think it's dystopian. I think it's the most utopian part of what we can imagine. I think it'll be really hard to reach that state.
Drones telling on you is pretty likely. I think it's a high chance of happening. And then a law that is bottom up, almost frictionlessly, I think is not so crazy. It is somewhat unlikely if you still have a government of elites, but why not?
Let's then move from the 5 years to, let's call it the next couple months, where we talk about, you mentioned a few use cases that you are all, working on, each excited about. What do you think we also mentioned sort of an adoption path, that this would be mostly invisible to users, that this would be mostly driven, mostly by institutions. There's the topic of data liability, also very important from an institutional perspective. You mentioned a caveat of how do you get rid of the liability while keeping the positive aspects of knowing everything there is to know about me even better than I know myself. Let's think about it this way now. Addressing an audience here, for example, where many of you are builders, you're developers, maybe some things that are going through your mind are, this is interesting, maybe I believe in it, maybe I don't. What does it concretely mean for me? How does it change the world that I care about in the next couple months? Maybe you mentioned, for example, proving like improving Ethereum blocks on very low or low to medium hardware devices. Is there anything more to say about that?
I mean, so Ethereum's goal is to go towards fully like a zkL1, where even it's not only zk rollups that are submitting proofs of execution and state transition, the L1 would do it as well. So the lower the hardware requirements, the higher the ability to join that prover set, and maybe to some extent that reinforces liveness or safety. But this is, I think, not lifelong, year-long evolution for Starkification of Ethereum. So in the next couple of months, it is more in the land of research, I think. But as Tomasz said, it's so exciting. The race is so fast-paced. Everyone is releasing new numbers every couple of weeks. So I think people who are following are excited by the evolution of it.
Is the pace of this change for Ethereum going at the pace that you expected, both of you? Or is it going faster or slower? Because everyone is releasing new numbers quickly.
So it's going as fast as Justin Drake expected, which is faster than anyone else expected. So practically all the progress matches his expectations for the last 2-3 years, which is pretty impressive. So keep listening to Justin Drake. People tell you that he's overly optimistic, but is hitting the target. And yeah, I think that's the excitement in the next 2 months. I think some of the things that I've heard from Justin and people for the next 2 months are already super promising, like the further progress and already matching some of the expectations, like some of the requirements that Vitalik set for people of like not only doing the real-time proving, but also doing real-time proving with like much lower energy machines.
Michel, what about at Nexus? What did the next couple of months look like with regards to client-side proving?
We're still working on the few generations of zkVM right now. Like recently, the latest one, we were working with the stool prover. And like one of the concerns that we had was first making sure that everything that we developed that were about the security loopholes and things, making sure that everything is designed with a very clear specification so that we know what we're talking about. Of course, there are still lots of things to do to get to real-time proving, but I think we're in the right path for that. I do believe it's like an important direction, but to me, I also see zk in general, zk technologies as not necessarily just about how fast you can do things, but also all the things that zk can gain. Like as I said, the private aspect of being able to prove this, it does not necessarily have to be real time as long as you gain something out of it. So usability is very important, making sure that and people can trust your system, know that its production eventually becomes production ready, that you can trust that. But yeah, it's a long way, but like using formal verification would be a very nice direction to be sure that eventually once the system gets used in practice, that people don't find all these trivial bugs, then they eventually circumvent the proof and can prove anything. So there are quite a few challenges, but also a lot of promising directions. And
can I ask why you chose Stu and also why you chose RISC-V as a zkVM target?
I think RISC-V was one of the reasons was because of all the tooling that has been available, so that you could still implement things on your favorite language and be able to generate proofs easily on RISC-V, so that was one of the reasons. Then I think, as I mentioned before, our first few versions were based on folding, which had a lot of, for instance, our memory checking was using Merkle trees, which was definitely one very slow thing to do. And the cycles of elliptic curves, it's a beautiful mathematical idea, but the actual implementation does introduce a lot of inefficiencies. And we thought, at least, that was important to move to small fields. It seemed to be a very promising direction, so we decided to change the whole arithmetization to be able to work with over Masen 31 groups, and that was a big change. Took a while to get the things done, but I thought it was an important direction, and I believe that it's something that even if we go back to folding, I think it's work that can be reused. It's not wasted. So it was important to follow that direction.
Oh, sorry, go ahead. So I wanted to say, this summer I'm looking at the right timer, but ending with you, how does the next couple of months or the short term look like with client-side proving at Starkware?
So Stu will prove the Starknet state starting, I believe, during June, I believe. We're in final stages of integration, so that's a big milestone. For client side, I hope that in the next couple of months we'll have big improvements on the performance for WASM. So anything web-based would be faster, and also we really want to release so we have a client-side version of Stu, an alpha version live now, so you can prove Cairo code. We want to get out a Cairo M31 variant. We already have airs for Stu for Cairo M31, but the language is doesn't exist yet, so we have to create the language. Also, we'll do some VM work, and we believe that this will speed up Stu by 10 to 50x, and that would probably make it viable to run on phones. So right now, you can run decent-sized programs on your Mac, M3, but I think phones would be really good. I don't know if a couple of months or a little more than that, but that's where we're going.
Yeah, in a couple of months, Stu is also going to prove Ethereum, which is exciting.
Yeah.
And then we're excited also to work on Cairo M31, maybe unlock. I think when we tried Stu recently on WASM, the main problem was RAM usage, because WASM limits you to 4, or sometimes you can bump it to 6 gigabytes. Sorry.
Yeah, so actually we have a PR now. I don't know what stage of review it's under, but it's good. Kind of has a lot of speed up for WASM. Yeah.
Okay, exciting.
Maybe one insight that I think that when it all gets to reality, then we will all become rollups. Because with all your private data and you're becoming your own sequencer and you just interact with the chain, so you're practically a rollup, and the reputation systems are solved because you can use your rollup as a reputation system.
To be fair, yes.
Could you duplicate your rollup and have 2 states and then you break the reputation system?
I wish it would help me with the workload.
Any questions to close us off? I don't see any hands. Then please, a warm applause for this wonderful panel.
Thank you for lasting an entire hour.
The whole hour, yeah. Applause to you guys.
Thank you so much.
Thank you all.